Hello everybody, and today we are going to continue from where we have finished at the previous session, and let me just remind you a little bit what we need to implement. So, as I already mentioned, we have a menu that has a selection, can be expanded or collapsed, and there is also an additional animation where appearance goes from light to a dark one. And let's go back and take a look at what we have already accomplished at previous session. So we implemented the menu itself, and it can be expanded, it can be open and closed, as well as expanded and collapsed, and it has a selection. So to say, we have all the basics that we need further on. And now let's move on to the selection part. Now let's talk about the selection itself. As you can see, it fades in when we select something, and it also fades out when selection goes away. And in addition to that, when selection goes from one button to another one, the background of the selected item goes below each button, which is pretty neat, by the way. And before we will go to the exact implementation details, take a pause and think about how you would implement this part on your own. Done? We can move on. But also, I want to give a brief introduction or a brief documentation overview of how it can be implemented and what tools we have. If we would go back to the UIKit world, we obviously could take a frame of a subview and just assign this frame when it gets converted to a specific hierarchy item. We would assign this frame to a selection view and just adjust it, animate it. So not a rocket science, obviously, but in SwiftUI world, you obviously can't do that. And the reason is because the previous approach in UIKit was clearly imperative one, while SwiftUI forces and pushes us all the way toward the declarative approach. And tools that SwiftUI offers are quite interesting, and I bet you heard of many of them. So let's start, of course, from the GeometryReader. I bet you heard of it a lot of times. The weird part, though, is that I thought it's being used in a very weird ways, while there are more tools that can help you achieve the same functionality. Anyways, GeometryReader itself, it offers you a sort of a frame to the hierarchy within, so you can get access to exactly to the layout data. You can store it through the anchors and do even more interesting stuff that we will touch a little bit later. And there are two more tools that we will cover later today. The one is matchedGeometryEffect. This one can be useful when you would like to move view, when you would like to synchronize the layout of two different views. That's not quite obvious how to do, but with matchedGeometryEffect, you can basically fade in one view from the position of fading out another one view, of the another view that fades out. And SwiftUI will synchronize layout. This is useful in a lot of situations. And the last one, but not least, is AnchorPreference. AnchorPreference lets you grab the layout data and use it for overlays and backgrounds. And you already get the idea, I think. We will use these tools to implement the selection background. So let's go back to the code. Having previous three options how we can manipulate the layout in SwiftUI in mind, we will use the first and the last one, the GeometryReader and AnchorPreference key. And for the AnchorPreference key, first of all, we'll start by grabbing the bounds of each button. And in order to do this, let's go somewhere here and add a class called the menu item geometry. It won't do anything that's hard to understand, so we will just declare the struct that will hold our data. Let's call it geometry, and we'll grab an item to which the geometry itself belongs to, and also the bounds of this item. And the bounds in SwiftUI cannot be used directly, so you literally cannot use the cdirect and pass it through the hierarchies. You can't do that, and the reason is because, as you already may notice, SwiftUI doesn't give you an access to the hierarchy itself, but it gives you a way how to do this properly. So Anchor, you may think of Anchor as a window to bounds. I mean, we can grab this bounds later on and it will be converted to a proper hierarchy automatically, and we will take a look at how it works shortly. Next, once we've implemented the geometry itself, we can implement also the preference item, the preference key. And before, we already have been using environments, and while environment works downward the hierarchy, the preference key goes upward. So basically, if subview will define the preference value, then the parent view will be able to read this information. So basically what we are going to do now is we will grab the bounds of the view itself, store it to the preference, and let the item list read this value. So let's start by implementing the preference key. The preference key itself declares very few values. The one is the function that lets you reduce the old item versus new item, and also the default value. And for the default value, let's say we are going to have a menu item geometry. We are going to have a dictionary. And for the reduce, obviously we need to merge the old values with preferences and the new one. So it was nothing, just to merge like that. And when we are speaking about using merging items and conflicting situations, we obviously want to take the last one, so the right hand side will fit perfectly. You may think of as old versus new rather than left hand side and right hand side. So this one's done. Then let's go back to the menu item list, and it is time to grab everything, to wrap everything all together. So we have a button, and it is time to store it through a preference key. So in order to read the anchor itself and to store it in the preference, SwiftUI offers a view modifier called AnchorPreference. So that's obvious naming. And for that, we are going to just use the key, and then there are a variety of sources that we can grab from the AnchorPreference. So basically, what this view modifier does is it lets us to grab the anchor of any of available options. As you can see, there are a bunch of, and store it into a preference itself. So we are only interested in bounds, and we will use this one. And the return value is going to be a value of the preference key itself. So here we are going to return an item and the bounds itself, because you may think of it as a bounds. This is going to be a bit better. Now let's try to build and run. It still doesn't work. Oh. Of course it won't. Build and run. Yeah, I already can see that we duplicated the knowledge of the item twice, but we will be able to optimize it later on. Before we will move on, let's simplify this code, because I can see a lot of duplication here, because if you will take a look, we already have a dictionary, so it doesn't make any sense to declare extra structure for that. So let's just simplify it. And also here, because the default value has been changed, as well as here. This line remains the same, because we still would like to have only the most recent anchor. And also, if we will go back here, we can get rid of the structure that no longer exists. As a result, we removed the extra structure, but functionality is still the same. Now, having all this knowledge in mind, we can try and implement the selection itself. Let's declare a view builder, and let's call it a selection background. Now, before we will implement the function itself, we can start from the background preference value. The trick with those preference value modifiers is that there are two versions. The one that lets you place an overlay, and the other one is the one that lets you to return the background. And as you saw before, we have a selection that goes below the button itself. So obviously we need here a background modifier. And for that, let's return the menu item preference key. And also let's go with alignment of leading. And for the transform, just give me a second. So what we did here is we basically are going to act on all of the gathered anchor preferences that we have here, and we can also actually return the selection right now. So the selection background is going to be based on the preferences, of course, like that. So this is just a dictionary, and GeometryReader. Let's return some view out of it. Let's for now just get rid of preview because it doesn't let me to implement the code. So first of all, we need to think whether we have a selection or not, because as you could remember, as you may remember, if we don't have any selection, then we have no background. We could of course manipulate the opacity, but I think here we can just get rid of the way of the selection view itself from the hierarchy altogether. So let's check if we have a selection. And also now it is time to use the preferences. So just to inline what we have here is, oops, I'm sorry, it's going to another part. Just to give you an understanding of what we have here is that basically, and this is crucial for your understanding, is that basically we have a gathered bounds per each item. And what we are going to do here is that if there is any selection, we can try to grab a frame out of it and then place our selection background in regards of below to this view by using its frame. So this is pretty straightforward, and I bet you could use the same technique with UIKit. So let's go here and let's map it. Now, as I already mentioned before, let's just rename it to a geometry. As I already mentioned before, anchor is just sort of a wrapper or through which one you can grab the actual frame value. And the way how SwiftUI wants us to convert those values into real frames is by using GeometryReader. And why is that? Because GeometryReader has exact understanding of its place in the hierarchy. This is hidden in its internals, but we don't care as long as we can use it API properly. So we can pass the anchor to GeometryReader, and it will automatically convert the value to be the frame. So if we will take a look at the frame, this is CGRect. Now we can just go with rounded rectangle, and for the corner radius, okay, let's go with 12 or maybe 3. And the frame, yeah, SwiftUI doesn't let you assign the frame itself, but we can combine multiple view modifiers like frame width and frame height, and alignment is the default one. And for the X and Y, we can just use the modifier offset, and for that we can use the frame min X, and for Y we can use the frame min Y. Now, how to get this view to a hierarchy from our background preference value modifier? And that's pretty simple. We are just going to use finally our below the geometry proxy. And here we just will return the background from the preference and from the proxy. And we can assign some foreground color. I know you don't want to have those row strings in your project, but it is the way it is here in our example. So just believe me, it is it was added. Now we can try to run this. Oh, I'm sorry, there is obviously a typo because I cannot construct a geometry proxy, but can construct GeometryReader instead. So let's build and run. Okay, looks good, and we already have a selection, and if we will try to go from one item to another, we can see that the selection goes just along, goes to a place where we tap. So looks good actually. If we will try to select the same button, selection goes away. You may notice glitchy animations from time to time, but again, as I said in the previous part, SwiftUI previews may sometimes be glitchy. So if you have some struggles with animation, please build and run on a simulator to ensure that code doesn't work, because sometimes it happens. However, this is not the end. Let me show you one more neat trick that would really be very complex to be implemented in UIKit world, while in SwiftUI, that's just a matter of minutes once you start understanding the idea. What I want to show you and where I would like to guide you is to be able to move selection through the buttons itself and through the labels, so that the selection would highlight, when it moves from one item to another one, it would highlight only the part that reflects the selection background itself. It doesn't look very descriptive to you, I bet, but just give me a shot and follow what I'm typing. So we will get rid of background selection, and instead we will introduce the overlay. So as you remember from my previous description, overlay gives you an ability to use all the gathered preferences, but the returned view will be placed on top instead of on the background. So this one's going to be exactly the same. Top leading alignment. We can remove the preview for now. And here we are going to use a pretty sophisticated technique where we will place on top of the menu itself, we will place the selected menu. So basically we will duplicate the same menu, and the selection will just only be visible through a mask. Let me show you. In order to do this, we can just go ahead and slightly duplicate what we have here. So we are going to return an item. And here action won't do anything because we don't want our selection to do anything whatsoever. And the label is going to duplicate the same label we had here. The only difference at this part is that this button is going to be selected all the time. And what's great about the view modifiers and environment is that it can be applied through a whole hierarchy. So here we are just going to add true, while here we can return false for now, or leave it as is. Oh, we don't need that selection. Now you may start wondering, okay, how are we going to render it? And just give me a second. So for the background, we are going to use the same, exactly the same background as we have here, but instead of a foreground, it's going to be a background. And let's take a look at what we have here. Okay, great. It reflects my intention perfectly. We have placed exactly the same menu on top of our default menu. And now the whole idea is to add a mask that will go through each item when it's selected. And in order to do this, we can just go ahead to the mask and return the selection background. And since we have preference here already, well, we can basically just copy and paste. The only difference though is that we don't need any selection color at all. Now, let's take a look here. You may notice that we cannot select anything. It doesn't work. And the reason for that is because overlay with buttons, it basically it basically receives all of our events, touch events. So we can just disable hit testing and rebuild. Still doesn't work. Oh, give me a second. I found the issue. Yeah. Great. As you can see, we have still the same functionality as we had before. So you may start wondering, okay, so what's the trick? Let me slow down our animation a little bit. So here in our preview view, we can just adjust the speed. So for example, we are going to use the 4 times slower. Oh, this one is 4 times faster. My bad. No, it is not. Or we can just adjust the duration. Yeah, this is build and run. Whoops. It's probably because there's a spring one. No matter. I will just use the linear. Great. We have resolved all the compile errors and let's give it a try. Okay, it looks like just the way it was before, so what's the point? And the point is that if we will try to reduce the speed of the animation and to use, let's say, a very slow speed, you can see that while selection goes from one item to another, it highlights text gracefully. I mean, look at this. This is really neat. And those sorts of small effects really improves your UI and makes it very interesting and appealing to user. Okay, cool. Now we can move on. After we finished with selection animation, it is time to get to the very interesting part where we will implement the custom transition. As you may see here, we have a custom transition when user selects from light to a dark scheme. So it fades out like a rectangle and it fulfills the whole background. So let's give it a shot and think how we can implement this. Before we will start, let's go back to the menu view itself and add one more item here before the logout button. It is already implemented in our code, so let's just add a selection to binding. Nothing special over here, as you can see. Before we will go further, let's just give a little bit overview of what we have added here just a second ago. So the color scheme picker is just implementation of the picker we have to implement, obviously. So it reflects this part of the UI. And the binding with the default initializer, that's our custom extension that lets you to bypass an optional value, and also add a default one in case there is nothing has been set. Nothing special, as I already mentioned. While override color scheme is sort of a mutation or review or revisiting, whatever is best, of the preferred color scheme. And the reason for that is because preferred color scheme takes effect only when view is on screen. When it goes away, then the color scheme gets reset to a default one. And since we have a menu, you already start understanding that when menu goes away from the screen and from the hierarchy, our color scheme will get reset to a default one, which creates a lot of glitches. So we don't need really this one. And you may take a look at the implementation on your own. But for now, just believe me that this updates the color scheme throughout the app and it works perfectly fine. After we added the color scheme picker, let's build and run to see how it looks like. And as you can see, it just simply fades between color schemes and does basically nothing else. So we can start from this part. And before we will really dive into the implementation, let me give you a brief overview of what we will use. When SwiftUI adds or removes view from the hierarchy, there is a special modifier called transition. And there is a special class called anyTransition that lets you do any custom animation that will be applied to a view whenever it enters or exits the hierarchy. You obviously saw this when you would animate the opacity, or you would add slide from any side, or you would add move from the edge and stuff like that. So there are a bunch of transitions. And the thing is, you can implement them on your own actually. And it doesn't look very crazy, and nor it is a rocket science. And if we will go to the code, there is a specific anyTransition that will give you a very deep understanding of how it works. So we'll just go ahead and let's say here we will try to declare a new transition. You may notice that there is a transition called modifier, and that's a whole extension point. Basically, how SwiftUI understands what it has to do during insertion or deletion is that there is a view modifiers that applied for the view that is being removed from the hierarchy, and the one that is being applied when the view is in the hierarchy, or you can think of like as active and identity. And the same applies for both insertion and deletion. I mean, it doesn't really matter. So Swift understands how to animate the difference between two view modifiers. So obviously those two has to be the same, so that SwiftUI can deduct the difference and animate it. And just a small sharing of how animation performed is that there is a special protocol in Swift called animatable, and it gives a hint to SwiftUI what data needs to be animated. So basically Swift takes a snapshot, or it understands the difference between the state of the view that was before and the state that view has to move to. And then throughout the animation, it applies it interpolates between those two values, and it can understand it by this animatable data property. That being said, let's move on to the custom transition itself. But before we start, let's just gather a few more basic points that we're gonna need in our custom transition. As you can see from our animated transition itself, the background fades in and expands from the frame of the picker itself to the whole available space. Thus, you already can see that we will need two frames that we will interpolate between. So in order to do this, we already have an AnchorPreference key, because as you remember, this is one of the way to grab the frame of the picker. We can just use the preference key and anchors, and we have implemented this already. The only interesting point that you may notice is that we are either using the newer value or the old one in case new one is the nil. And reason for that is after layout has been finished, SwiftUI looks like nils out preference key for this anchor to a default value, which is nil of course, so that we will lose our valid frame, and this is not something that we really need. So this is the reason to have either new or old value. And let's just add AnchorPreference as we had before. Of course, we are going to use the cdirect. Oops, it doesn't want to work like that. Anyway, AnchorPreference. And since we are going to use the bounds, the type is going to be cdirect here. We will add just the bounds. And for the transform, there is basically nothing to transform whatsoever. So we can just return the very first argument. One more thing that we need to change is the way how we declare the background is from the background to a background preference value. And just say that we are going to be interested in anchor preference. And here, this is just a picker frame or picker bounds, whatever. And we finish with all of the preparations, and it's really time to move on and to implement the custom transition. So for that, let's just add a new file and call it the menu background fade in modifier. Oh, I'm sorry. I would better call it transition. And let's import SwiftUI, of course. And as I already mentioned before, SwiftUI lets us declare our custom transitions by using a modifier extension. So we will just use an extension to any transition, and let's call it menu background fade in. And here we are going to pass the anchor of our toggle, of course, the place that we will start from, and return the transition. One more interesting method that any transition declares is the asymmetric one. So symmetric and asymmetric, well, asymmetric lets you to use custom transition for insertion and the custom transition for removal, as you can see. And here we will use just our custom one. And let's start from opacity just to silence compiler errors, and the same for removal. And it's finally time to declare our menu background fading modifier. Let's call them view modifier, and let's give it a shot. And also let's figure out whether it is an identity or not. And we will use this value later on. And also, as always with view modifiers, we need to declare content. Once that's done, we can then use the modifier for our insertion transition. And let's say we are going to return here our background modifier. This is anchor, and we can just copy and paste for now. Except that we will change the identity flag to true. And maybe we can also change the removal to identity. And let's apply our custom transition straight away. So for that we will go to the menu view, and we will say that there's a transition and our menu background transition from picker bounds. So far so good. We can try to build and run. Wait for the compiler to figure things out. And nothing has been changed so far, which is good, because if we will go to our menu background, you can see that the view modifier does, well, basically does nothing. So now it is finally time to implement it. And from the start, let's go from the GeometryReader. As you know from the behavior of GeometryReader, it takes all the space that parent offers to it. So during the layout process, the proxy frame is going to have the whole available frame of the parent, which is basically all we need when we transition from the picker frame to a parent one. So it might be an answer if you have ever come up with question like, how are we going to understand the final frame? So the GeometryReader already have the whole knowledge of the final frame. The only point that we need to focus is to start from something. So the only point that we need to take into account is the picker frame that we will start animation from. So let's just for now understand which frame we are going to use, and for that we will declare a special method. What we need here is to figure out whether we have an anchor, because if we don't, that's invalid citation, but we're just guarding it. And also, if that's an identity, then return a default. Okay, so by having these lines declared, What we are basically saying is that if we don't have any anchor, and that's invalid situation, we don't need to return the whole frame available. And the same applies if that's an identity. Oh, sorry, if that's not an identity. So let's now return the proxy for the anchor. And just as we did before, GeometryReader let you transform the proxy to exact value, and we can use it like that. So we can declare a frame now, and just as before, we don't have any specific view modifier that accepts the whole frame, so we'll just type in manually frame height and width, as well as give it a offset. Oh, here we probably, oh, okay. Frame minimum X and minimum Y, of course. Once that's done, I bet we can give it a shot. Probably it was running it on the simulator. Okay, it doesn't work. And you may start wondering what's wrong with our transition. And the thing is, everything is perfect. It just doesn't work. And why? Because if you will take a look here, the menu background always remains the same. And this is the time when we need to step back and talk a little bit about how SwiftUI understands whether view needs to be added or not. As you may heard, SwiftUI has two identities. The one is the structure one, and the other one is explicit identity. So basically, here you can see that for the SwiftUI, the structure remains the same. That being said, if we would use the switcher, and let's say we would switch over our color scheme, then for SwiftUI having separate cases, then yeah, it would be structurally different views, and then it would animate between those, because obviously for SwiftUI this is the new view, so the old one has to go away. But this is not the way how it works, because imagine we are going to have like tons of cases. So for that, Swift has a special view modifier called ID, and it essentially provides us a way to tell Swift that this view not only is structurally unique, but also has a additional modifier that says whether view is unique or not. And for that, we will use just a color scheme. And like that. Now we can build and run. Oops, something went wrong. Animation doesn't work. So let's use the simulator. Okay. Oh, okay, I see how it works. Now we can try and see that even after adding a transition, it really doesn't have any effect. And you may start wondering whether you did something wrong or not, and the answer is obviously not. If we will take a step backward and take a look at what we've done, we can see that we are telling Swift to use a transition, but remember, transition applied only when SwiftUI inserts something or removes something from the hierarchy. And for the Swift, for SwiftUI, there is basically no reason to do this with the menu background, because it is always the same. If we would switch the current color scheme, then and returning the different menu background from each case, then for the SwiftUI it would be a different structure, and return view would be a different value, so it then would apply the transition. However, this is not the case, because imagine having really a huge one. And to handle this, Swift has a very neat view modifier called ID. And ID is another part of SwiftUI identification system, and it is explicit basically. So you can think of structure one and explicit. And we will explicitly tell Swift that this view is the new one. And the ID that will declare the view explicit identity is going to be the color scheme. That being said, whenever color scheme changes for the SwiftUI, it is going to be a whole new view, and it will apply finally our transition. So let's try and return either a color scheme or a system color scheme. You can also notice that something went totally wrong, and I already understand that we are missing an update to a condition, so it should be only when it is not identity. So there was a mistake with the fade in modifier that would return the whole frame when view is not identity, which is incorrect. So let's build and run and try to switch. It doesn't work, but if we will run it on a simulator, just as I said before, not all of the animations are working perfectly with SwiftUI previews. I honestly have no idea why it does like that, but if we will take a closer look, you can see that even after animation applied, it still has some flashing. It doesn't work perfectly, and if we will try to slow down animations, you can see that the whole issue with UI glitching. Whoa, Swift has crashed. Great. This is an unexpected part, honestly. We'll switch off the animation slowing down. But if you will take a look here, you can see that the old view gets removed. And that's the reason why we can see the white background after animation started. So how we are going to fix this? We are going to add one more view modifier. So let's go to our transition. And as you can see, with removal, we have an identity. So we can just add another view modifier, and now we will finally utilize an animatable property. Honestly, we won't do anything whatsoever, so we can just return the content. But what we are going to achieve here with our custom transition is that we will force SwiftUI to keep our view on the hierarchy throughout the whole animation. And how we can do this? By declaring animatable protocol, we can just use basically anything. And here, for the view modifier, we can just return, let's say, view background modifier, fade out. And here, let's say we will set animatable data to 0 and here to 1. Now let's build and run. Is it working already or not? Oh, it is launching. Just a second. And after simulator figure things out, we can see that the old view now fades out only after animation has been finished. And if we will take a look a little bit more at how transition works, just as I mentioned before, we are actually tricking SwiftUI to keep this view modifier all the way throughout the animation. And if we will play around and pass the 0 over here or 1, you can see that basically it won't affect in any way. But you can become interested why we don't have animation here, but the frame is animated no matter what. And the reason for that is that frame and offset are animatable on its own. So we are just using this functionality out of the box for free, which is great. So far so good. As you can see, throughout the 2 sessions, we were able to implement a pretty sophisticated menu app with a basic interaction, so it doesn't support gestures. However, it has some neat animations, it has selection, it has switching of the color scheme, and even custom transition. So I bet now you have way more understanding of how SwiftUI works, and I hope you will apply this in practice. And stay tuned for more. Have a good day.